into this, what is functional programming? So there's not going to be a lot of code that I'm going to show. It's mostly going to be talking about concepts in functional programming. There'll be a little bit of code and talking about what people mean by functional programming and how we might want to broaden what people mean by functional programming to talk about some other stuff in this meetup. So first of all, if you're going to talk about functional programming, it's going to talk about what a function is, right? So at its base, a function is a map between inputs and outputs. Specifically, it's a map so that for any set of inputs, you get one output. Of course, you can define this in a lot of different ways. Sometimes you'll see a table, like right here, you'll have a table where you have inputs on the left and outputs on the right, or you'll see it in like a more mathematical setting where you have like a f of x and then some transformation on x. And then, this mathematical definition of a function is a little bit different than the way we use the word function in programming, which generally means procedure. We mean some place where we're going to run a piece of computation and then bring the results back to the main loop or the main part of the program. So when functional programmers say functional programming, they mean viewing your computation through this lens, through this idea of inputs and outputs. And the closer you can get to that, the more like functional programming, the more functional programming you're doing. Yeah, so like I said, what is functional programming? Common answer, the basic unit of computation is a function. So that being said, when you actually do functional programming, a lot of times it doesn't really look like what you're doing is writing down functions and then computing inputs and outputs. Instead, things look pretty crazy. And this is a sample of Reason. I could have just as easily put a sample of Haskell or Scala or really any functional programming language I've ever used. While I can understand how I'm using functions, it oftentimes doesn't feel like that's what I'm doing. So I wanted to talk a little bit, about what is it that we're getting. If it's not just about inputs and outputs, what is it that we're getting out of functional programming? But first, I was really curious, just how many of you have actually written programs in a functional setting before? I guess raise your hand if you've written functional programs before. Okay, pretty good. Probably about half the group. So that's awesome. And I guess raise your hand if you'd like to do it again. I guess judging from being here, that's really great. A lot of people haven't. A lot of people don't really know what it is that functional programmers are talking about if they've ever heard of it at all. So I'm going to try and go through some of what it is. So before I was talking about what a definition of functional programming is, and I'd say it's computation as a base unit of a function. But to try and be a little bit more intuitive, maybe it'd be better to stop and think about what do functional programming languages have in common. So also, what do people who do functional programming, what do they seem to want out of the languages they're using? And then if you're not a functional programmer, why might you want to learn about it? Whether you go and get a job as a functional programmer or not, you might still want to know about it for several reasons. And then lastly, what kind of problems are really does this stuff really work well for? All right, so first, what do functional programming languages have in common? So I would say even above mapping inputs to outputs, the idea that functional programming languages really have in common is separating the transforms of data from the data itself. Compare that to an object-oriented approach where you're defining a class, and then that class is going to have methods. So in fact, you define your data first, that's the class, and then you define the methods that operate on the data. In functional programming, instead, you're going to define a set of functions that take data, and then it's up to those functions to define whether that data is acceptable or not, either through a type system or through a set of conditional checking and contracts. But the reason that you would want to isolate the transformations of data from the objects is maybe subtle. Does anybody maybe have a thought of why you might want to split your data from the objects transforming the data? So so he said you don't know what data you have, and I think that's a really good point. And what that might mean is you do know what data you have right now, but you don't know what data you're going to have. So what you can do with a function, if you're dealing with just a transformation, you can extend that transformation in the face of a lot of different data without having to modify all the different definitions of that data. So another reason that you might want to separate data and transforms is it makes it easier to write correct programs. So a lot of the rest of this is going to be about program correctness. And at least when I was in school learning about programming, program correctness was almost an afterthought. I felt like, like there was you maybe had like one proof class, maybe had like just a little bit of talk about it, and then the rest of the time was, hey, go out and write there. If your program does what it's supposed to do, it's correct, right? Like, what else more do you need? And I think that's a pretty decent way of thinking about programming until you hit more complicated systems and more difficult problems. And then suddenly it starts to fall apart, and you really want to know that your program is going to be robust to varied inputs and is going to behave in an expected manner. And I think that more than anything is what functional programming allows you to have, are programs that behave how you would expect them to behave. Yeah, so what do programmers seem to want? So I'm going to answer that for me, at least, the thing I care most about are programs being correct. Obviously, I need them to run fast, but if I wanted just speed, I'd be writing in C, which I've done and didn't like. So here I am writing programs in languages much slower than that. What are some other things that you guys think that functional programmers, like, what do you care about, or what do you find valuable? Yeah, so he said transparency in your code, and I think that's a really big thing, is being able not just to have a correct program, but to make it so that everybody can tell that it is, right? Like, those two things are very important. So in fact, like, my next slide this is all going very well. Everybody's answers just lead me right into the next thing, so that's awesome. So like, obviously functions make it easier to determine inputs and outputs. That's actually in the definition of a function, right? So it should at least be able to do that very well. And in addition to that, it makes it easy to see what your code is doing. And I have an example coming up to show that. So I say that functional programs make it easier to write correct code because it makes it easier to determine what's coming into your program, what's going out of your program. It's easier to demonstrate that your program is correct, either in the form of a proof or just casually, just like walking someone through it. Because you have inputs and outputs, it becomes much easier. Yeah, Jordan.
Another reason, too, is that non-functional code tends to side effect a lot. So I might, be in a function and then I'm going to alter some state somewhere else, especially object-oriented programming where I have encapsulated data types. And when you're in functional programming, since you're not relying a lot on side effecting, it's easier to reason about the code locally because the function does exactly what it does and it's not touching a bunch of other things. And then you can write like tests and stuff that are fairly localized, so it makes it a lot easier to compose.
Oh yeah, so Jordan was saying that the fact that functional programs tend to they tend to discourage side effects. So when you write a functional program, most functional programmers tend to write their code so that the inputs and outputs of their program are the only things that are going on. So because of that, you don't have to worry about some encapsulated state changing on you that you didn't know was going to change, possibly by some other part of the program. That's a huge thing, and that property of things not changing on you without you expecting it, it allows the composability and allows so many of the nice properties of functional programming. In fact, I have a whole slide dedicated to composition. So I think this really shows, like, people who do functional programming, like, we're all wanting the same things. Like, we're all wanting our code to be easy to read, easy to reason about. And then the composition is really important because it's no good to just have one small piece of a program easy to read and easy to reason about. In fact, I'd argue you can get that in just about any dynamic. Like, you can always come up with a way of writing one piece of a code and make it so that people can follow it. What becomes difficult is whenever you have multiple developers or complex systems and you're trying to compose those pieces together and still feel good that each piece independently and as a whole is correct. I mean, I'll tell you, I don't want to act like functional programming is a silver bullet to that problem. I think that is the problem in computer software. I would say functional programming is a great tool to help with it. But if you have a better idea for how to do it, I'm all ears. But that I think is a very, very powerful property of functions. Because you're mostly dealing with inputs and outputs where you don't have side effects, you can compose sets of inputs to sets of outputs to develop more complicated behaviors. So I'm going to do a very, very simple example of proving a function. So raise your hand if you ever had to do any proofs in your either CS courses or on your own. Yeah. So I see like 4 hands up, which I mean I think I did I think I had to do Hoare logic proofs in one class, in a CS theory class. Let me tell you, this isn't going to be that. You're going to be very happy with this proof. So it's really silly. So first we have several suits. So we have clubs, spades, hearts, and diamonds, and then we have a color, red and black. And we're going to write a program that tells you what color your suit is based on what suit it is. So its input is going to be, oh, I have this backwards. That's so bad. This should say suit. So it can't prove your naming's right. It can only prove your structure's right, which I actually have a slide about. But yeah, so suit, and then the case of suit is going to either be a club, a spade, a heart, or a diamond, right? There can be no other input because we've defined our input. There can be no other output because we've defined our output. So the proof is unbelievably easy, right? It's just a proof by termination. You just prove termination by exhaustion. You have all your inputs. You just simply work through every single input, and then you have all your outputs. That might seem like a little thing, but I mean, the fact that you have completely bound your input for that problem and then completely bound your output means you never have to worry about something like that being wrong. You can imagine taking this and adding more complexity. Maybe it's a club with a number and a spade with a string, but in each case you can work through the same sort of idea and be very, very sure that that part of your program is correct. There's no way that side effects can happen. There's nothing in here that can mutate something else. And I made it a ridiculously simple example on purpose. And there are, plenty of examples where it does get just too hard to prove something. But the fact that you can decompose the pieces where you can prove it, you can decompose the program into pieces that you can prove, and then just leave as a kernel the part that's really hard to prove, and then write tests around that piece or monitoring around that piece, instead of having to consider all these other pieces and test through all those other pieces. I think that's a really powerful and worthwhile technique. But yeah, so if you're looking for something more than this for the proof, then there isn't anything. Like, I mean, I could write like a QED. I could write QED at the bottom, I guess, and then we'd be in proof land for real. But that's what I want to say. Like when functional programmers talk about proving things, sometimes you're using things like structural induction and like complicated methods. But I mean, that's not that complicated. But a lot of times it's just this. It's the fact that you can actually read your inputs and outputs, and because you can read your inputs and outputs, you already know what the function does. And it's a very short argument if you're talking with another developer and you read through your inputs and your outputs, and you guys all see what it does. And usually you discover that somebody typed color instead of suit in your function. Yeah. So if you're not a functional programmer, why might you care about these things? And this is kind of what I would go back to is like all programmers when they're writing code have to decide when their program is correct. The standard that you use to define that depends on the kind of code you're writing and the environment that you're writing. A lot of times deadlines and schedules make it impossible for people to prove every single part of a program correct. So you have to answer that question in some way or another, and it's good to have a good definition of that. You should also know what parts of the program, what parts of your system you don't know the answer to that question, like what is correct behavior, what is not correct behavior. And that's surprisingly common too, especially in microservice systems. There are lots of microservices that are defined where parts of the system are just undefined. Like you don't really have a good answer to what that behavior should be. It happens, the behavior happens, but like why it happens is often left as an exercise for the user. And then I think another part of this is, okay, so you have your business deadlines, you have all of that stuff, but can you confidently say that over time the code that is in your system is getting better and not worse? So as you add features and add pieces, are the things that you're writing making your code base better? Do your refactors actually reduce bugs? Things like that. I think that the answers in functional programming are all very solid for all of these things, especially the last one. At our company, we do a lot of fast development, very fast development, and I think it's a huge benefit that we can then go back and iterate that the code that we've written and make it better each time and feel more and more confident in it. Yeah, so I think a lot of the times the answers to the questions about how do you prove a program correct are cultural, right? So you write tests, you use test-driven development, you check for code coverage. And I think that those are great answers. I think everybody should be doing that. You definitely should. What I feel like is that we can have a little bit more. But I do want to talk, specifically I want to talk about Ruby people because that's a community that I've never been involved with, but I listen to a lot of podcasts, and one of the podcasts I listen to is a Ruby podcast. I'm always impressed with the way that they talk about naming, and they pay a lot of attention to the way you name things and the way you write your code. I think a lot of that has to do with the fact that it is completely untyped, and so much is changeable and so much is flexible in the Ruby language. So you have to be very careful about cultural things. Like naming conventions and testing conventions, stuff like that. But I guess this is where the reason I wanted to bring this up was to talk about like why you might care about functional programming even if you're not going to be a functional programmer. It's like I find value in learning about other programming languages, even though I probably am never going to write any Ruby code. I never say never, but I've never written any. But it's still very interesting, and I learn a lot learning about that language. So I think that to write good systems, you have to use everything that you can possibly use. So great culture is important, and managing complexity technically also is important. And I think that the technical management of complexity is where functional programming really shines. So that leads me into the next part of what I want to talk about, which is what I want this to be. I would like to see us take this meetup and turn it into a meetup where we're talking about tools and techniques to write better code that are not sort of on the culture side, that are more on the technical side. And especially ones that are outside of the mainstream. So, I think choosing an alternate programming language for this is definitely outside of the mainstream. I think theorem provers would be outside of the mainstream. Some languages are kind of like right on the border, like Rust. Rust is becoming pretty mainstream, but it's still really interesting. And then FP adjacent subjects, just like the core of functional programming are functions. Well, once you introduce the idea of a function, there are all these other concepts in mathematics that are related to functions: logic, type theory, category theory, and then linear logic. As a subdiscipline of logic, but I want to call out specifically because of Rust. And so I would love for us to start doing some talks about each of these categories. I know Jordan's done a few on category theory. We've had a few of those. I'd love to see a type theory talk, or if somebody is a Rust expert, I'd love to see a talk about that. I think that would be a really interesting topic. And then other languages, like I said, I mentioned Rust a couple times, but Prolog and Datalog are two other ways of approaching this problem. So they have a very different approach from functional programming in a lot of ways, because you talk about outputs, and then you let the computer determine the correct way of resolving those outputs, to capture those outputs. But it's a different sort of transparency. But again, it's about writing correct programs. You know, you write a program where if the only thing you're specifying is the output, then you know you have the output. So I think that's a really interesting property as well. And then theorem provers, I'll probably have someone do a talk on TLA plus. We've started using it at our work and have been very happy with the results. And it's a way of specifying a program, regardless of whether the programming language you're writing in has the tools to do that kind of specification. So it's like something I could see be very, very valuable if you're working, say, at like a data science shop and you're writing a lot of Python. You don't have some of the advanced type tools. Writing a specification can be really nice. Of course, we use Haskell, and I still find it incredibly valuable because you can then actually write a one-to-one mapping between TLA plus and Haskell. But yeah. And then also, I kind of like to try a few different kinds of talks. You know, this is great, but you know, if somebody doesn't feel like they want to come up here and stand and have everyone stare at them, I can understand why it can be a little intimidating. I know I feel a little intimidated when I do it. I'd be glad to, first of all, come up with someone and just talk to them about their topic. Like if you want to do like an interview style thing, or if you don't want me to talk to you because you don't like me, which I also understand, we can bring a buddy, so you can have somebody else talk with you about it. Or if you want to do a group talk, I'd love to see that. Show and tell is really nice too. So if you have some super cool project that you've been working on, you know, that you're allowed to show, or if you're not allowed to show and you don't care and you want to show it anyway, I guess I don't care, but yeah, bring it up here and then show it off, and we'll make sure we ask questions, and you know, we won't let you just swim and drown. So yeah, also solve a problem. I think we're going to do a couple talks where maybe we propose a problem and then look at different ways of solving it in functional programming languages and other languages. I think, hopefully, you know, I don't intend to pick very complicated problems, so it's going to be like finding the, you know, I don't know, the prime, you know, decomposition of a number or something like that, or, you know, reading a string and finding all the F's in the string, you know. I don't, because it's hard to do anything more complicated than that in a talk. But that's a great way of, like, say, if we want to do a language comparison, like maybe comparing a solution in OCaml to a solution in Python. I think that would be fun. I actually wrote a couple of those that I'll show after this. But yeah, and then I'm also open to any other suggestions about ways to do stuff. But I think that it's really neat that we have something like this, and I'd like to see it grow and become more interesting. So there's a few more things after the thank you. I got my slides out of order. There we go. So I'll come back to the thank you. So yeah, Jordan, right before this started, he reminded me that maybe it'd be useful to put some links to things, and I'll Slack them in the channel. But one really good resource for learning about goings on in functional programming communities, there's a Haskell newsletter. I subscribe to that. It's the main way I learn about stuff. That like summarizes what's going on in Haskell, and a lot of times they'll talk about other programming languages too. And then if you're looking for something fun to do and you're looking for a functional programming project, there's this ICFP contest. So that's, I don't know, IC, whatever that stands for, and then functional programming. So we do this contest at my work every year for, I think, 4 years now. And oh, yeah. See, I didn't want to say that because it's like maybe it's French, and so I'm not going to just say that. Yeah, international conference is what Jordan says it was. I could have guessed that. And then, but the contests are really interesting. So one year there was they gave you these files for a 3D printer, like a magical 3D printer they made, and you had to verify that you could build the object that they said that you could build. I mean, obviously it's all just virtual, but it was really neat. Another one was you had to find the shortest path for a gondola going through Venice, and that was really interesting because you learn a lot about shortest path algorithms and how, like, you know, that's a really hard algorithm. I mean, you probably already know that, but you really feel it when you try and build something that has to run in under a minute. So, and it's got 40,000 nodes to compute, and it fails. So, one was we folded origami. So, like, you had to fold all these different shapes. They gave you like a map, and you had to try and fold that shape. We managed to fold a piece of paper in half. I called it halfagami, and that's as far as we got, but I was pretty proud of that. Yeah, so it'd be really neat. Maybe we can try and do one of that. If everyone's interested, we could try and do some of that as a group and like not just be like all isolated. All right, ready? Thank you. I got it in the right order now. Does anybody have any questions for me?
Yeah, so I'm guessing in your workplace, you actually use the functional programming concepts in a production environment, or only like, oh,
You mind starting over?
mic,
Thank you.
okay, it's on. Oh, okay. So in your own workshop, do you utilize all the functional programming concepts in a production?
Sure. Yeah. The company I work for is Plow, and we use Haskell for something like 90% of our backend code, and then we use Reason now for something like 90% of our front end code. So we have functional programming all the way up and down the stack. We use a little bit of C for some stuff, and we use Nix now for doing builds and deployment. So that's a functional programming environment for sort of building configurations to deploy software. So we're all in on the functional thing. For better or for worse, we're all in.
Okay. So was that was your first exposure to functional programming then through your current position, or was this something that you sought out because Plow was known for embracing those concepts?
Yeah, so I'm one of the founders of Plow, and so we selected it because I liked it. They were using PHP and C# and MySQL, and they were running the MySQL on a Windows server, and it was. Look, I mean, the programmer who did it before me, I like him a lot. He's a good guy. It was just I didn't know those languages. I knew Haskell and Lisp, Scheme, and C. And the idea of developing a website in C sounded like the worst thing in the world. So I decided I was going to rewrite it all in Haskell, and I did that. But I'm happy with that decision. That was 7 years ago, so it's been a while.
No further questions from me. Anybody else?
All right. Well, thanks, guys. Also, I guess another thing is if anybody has talks, feel free to message me on Slack or just message in the channel. But I'd really love a Rust talk. If anyone's doing any Reason, I'd love a Reason talk or a Haskell talk. Really, just anything. We had an Erlang talk a long time ago. I feel like maybe it's time for another Erlang talk. So, all right, guys, that's all I have. Thank you so much.